So the weekly homework related to the Hooke's law questions. If you have doubt, you can mention. Question number 1, any doubt in question 1? Question number 1, any doubt? No doubt. Question 2, any doubt?
Sir, I have a question.
Which one? This question 2
Could
or
you
1?
please state the answer as well?
Okay. So for question number 1, the answer is B.
Okay.
Okay. For question 1, the answer is B. Question 2, if you have the doubt, you can mention. Question number 2, the correct answer for this one is B as well. If you have doubt, you can mention the doubts as well. You have doubt on
I
1?
have a doubt. How do we get 17.3?
How will get 17.3? Because the length is a extension plus the original length. When there was no load attached to the spring, like we were having a spring which is 15.2 centimeter long. And when we add a load of a 2 Newton, it has extended or increases by how much? The length increases by 2.1. So the question is, what is the total length of the spring? So what is the total length of the spring? Originally, it was 15.2 and it is extended by 2.1 or increased by 2.1. So what is the total length of the spring? So 15.2 plus 2.1, that will give us 17.3. So we'll add the original length plus the extension, we'll know the total length of the spring.
Okay.
Okay. For question number 1, in question number 1, as we know, the mass of an object does not change as we move from one place to another. The mass remains constant. So the diagram shows a beam balance and a beaker with a wire loop balances the standard masses. The beaker is then removed and hung from a spring and extended by 5 centimeters. The experiment was repeated with the same apparatus on the moon, where the acceleration of a free fall is less than for Earth. Which statement describes what happened? So, like example, as we know, the mass does not change, the mass remain constant or same. So if we use the same apparatus on the moon, it will remain balanced because the mass is not changing. It's a comparison here. But what happened? As the moon is having a weaker gravity, so the weight of an object, weight is a product of mass and gravity. The acceleration due to gravity or the gravity of the moon is less as compared to that of the Earth. So if the gravity of the moon is weaker, it means the weight of an object, it will be lighter. As a result, the spring will not stretch to the same 5 centimeter. It will stretch less than 5 centimeter. It will stretch because on the moon there is a weight, but that is not same as the weight on the Earth. Because the weight is causing the extension for the spring balance. So lighter the object, as smaller the extension it will cause. So on the Earth, it causes extension of 5 centimeter, but on the moon, the extension will be less than 5 centimeter. That's why B is the right answer for this.
Okay, sir. Thank
Sir, I have a question.
Yes.
What does the beam is balanced? What does this mean?
Beam is balanced means like the left hand side and the right hand side have the equal mass. It means the beam is balanced, or the moments, the turning effects of both sides are equal. Like if I say this is 3 gram example, so this is also 3 gram. So the beam is horizontal or the balanced. Question 3, any doubt? The correct answer for question 3 is D. Because we need the extension. Extension is a measured length minus the original length. If you want explanation, I'll explain. But if you don't want explanation, I will just state the answer. Question number 4, when we plot a graph for force and extension, it should start from origin. When there is no load, there is no extension. That's why it should be D. Question 4. Question 5, what is the name given to a force that stretches? As we just discussed now, weight is the force which will stretch. So D will be the right answer for this. what is the extension? Extension means increase in length. Originally it was X and now it is Y. So how much it is increased? So it will be Y minus X. So D will be the right answer. Like if I say this is 10 centimeter long and this was 3 centimeters. So how much it has extended or increased? So it will be 10 minus 3, which is equals to 7. So the difference in the two lengths will give us the extension. Question 7, any doubt? The correct answer for question 7 is C. If you have doubt, I'll explain. Otherwise, I'll move on to the next question.
Sir, doubt.
Okay. The object with a different mass are hung on a 10 centimeter spring. The diagram shows how much the spring stretches. We know extension and the weight is directly proportional or mass is directly proportional. If we have a 100-gram mass, if there's a 100-gram mass, how much is the extension? Like it was 10 and now it is 20. How much it has extended or increased?
10.
10. So it
10.
means 100 gram is causing a 10 centimeter extension. When we add a load M, the extension is how much? The total length is 30. Originally is 10 and the total length is 30. So how much it is extended or increased? So it is increased
20.
by 20. So M is causing a 20 centimeter extension. We just cross multiply, like 100 is causing 10, M is causing 20. We just cross multiply. So when we simplify this 100 multiplied by 20 divided by 10, that will give us M. And when you simplify, you will get 200 gram. Because the extension or the increase in length is directly proportional to original length. Or extension, I mean. So if the higher the load we apply, like greater the load we apply, greater the extension of the spring. Is it clear?
Yes, sir.
Question 8, the extension of a load spring graph is there. The question is when an object of an unknown weight is hung, the length of a spring is 16.4. Originally it is 15 and now it is 16.4. So how much is the extension? Because the graph is for extension and load. So if originally it is 15 and now it is 16.4. So how much it is extended? It means it is when we subtract, so it will be 1.4 centimeter extension. Because extension is the new length minus the original length. When we subtract, we got 1.4. So from 1.4, we'll draw a line. Here 10 boxes equals to 1, so each is 0.1. So this is 1.1, 1.2, 1.3, and 1.4. So this is 1.4. So from 1.4, we draw a line and find how much it is, what load is causing an extension of 1.4. So that is 3.5. So C will be the right answer. And why we calculate the extension first? Because the graph was extension and a load graph. That's why we plot a graph, that's why we first calculated the extension. Is it clear?
Yes.
Yes.
The next question. The next is, these are the structure questions. Question number 1, if you have any doubt, question number 1A, part B, and part C. Any doubt?
Teacher, part B, I have a doubt.
Part B, okay.
Yeah.
Now, how to solve part B? The question is a force up to 120 Newton, a spring obeys force up to 120 Newton, spring obeys a Hooke's law. A force of one, so, and they mention a force of 120 Newton causes a 64 millimeter extension. So when the force is 100, the extension is 64. What is the 64? 10 boxes equals to 20. So each is representing 2. So this is 62 and this is 64. So 64 and 100 will mark a point. And because it
Sir,
is obeying,
100.
yes, 120 I mean. So here 10 boxes equals to 50. So each is representing 5. So 105, 110, 115, and 120. So this is 120 and 64. So I guess this one 120 and 64. So because they mention a force up to 120 and extension 64, it obeys the Hooke's law. Obeys the Hooke's law means force and extension are directly proportional, or it must be a straight line. So we'll have a straight line till this point. So we'll sketch a graph and it should be a straight line till 64 and 120. And the second part of the same question, they ask calculate the spring constant. So how we can calculate a spring constant? Spring constant is force divided by extension. So force divided by extension will give us a spring constant. So force is how much? 120. And the extension is what? 64. So 120 divided by 64 millimeter. So what we will get? We'll get like 1.9 Newton per millimeter. Is it clear? That's for part B2. Calculating a spring constant. So for a linear region, for a straight line region, we'll take the force. You can take any force and a relative extension. But if the values are given, like the force was 120 and the extension was 64, so I will use that value. But still it will work with any value. Yes, Abdullah, you have a question? Yes, Abdullah.
Sir, what I have written it 1.875 Newton
Yeah, it's
per
fine
millimeter.
because 1.875 is the right value. But usually, as I mentioned, when you write the answer, write to 2 to 3 significant figure. So you should either write 1.87 or 1.88, or you can write 1.9. So when you write your answer, keep like 3 significant figure, 2 to 3 significant figure answer is the right. Okay. Question number 2, any doubt? Question 2, part A, B, C, D. 4 parts are there. Anyone have any
Sir,
doubt?
I had a doubt in question number 1, part C.
Question number 1, part C. In question number 1, part C, a student makes a spring balance using a spring in B. The maximum reading on the balance is 150. Student tests his balance with a known weight of 140 and he observed that the reading is not 140. Suggest and explain, like what is the question? Student used this spring to design a balance. Like the spring is there and this will have the number like 0 is there, 10 is there, 20 until 140. So when he add a load of 140 Newton to this spring balance, he found that the reading is not correct. Like the balance reading is not giving us 140, even though he attach a load of 140. So what could be the reason for that? The reason might be because we assume that the spring is obeying a Hooke's law, but what might happen when a heavy load is attached, that spring might deform or spring may not obey the Hooke's law, or the force and extension are not directly proportional to each other. And if the force and extension are not directly proportional, means we have crossed the elastic limit or the limit of proportionality. So we have to suggest and explain the reading is why it is not, because if it is obeying a Hooke's law, force and extension are directly proportional. But if it is not obeying the Hooke's law, then the force and extension are not directly proportional. So for that force, the extension will not be same what we expect. So what could be the reason? Suggestion is there that spring does not obey the Hooke's law and it exceed the elastic limit, you can also say, or you can also say limit of proportionality.
Sir, can I also say that the spring may be damaged?
You can use the term, but that will, you have to state and suggest and then explain. So the correct, if you mention spring is damaged or deformed, you will only score 1 mark for that.
I have written the spring may be damaged or it may not be obeying Hooke's law as the extension is not directly proportional to the stretching force.
Yeah, 1 mark is for writing spring is not obeying Hooke's law, or it is not like force and extension are not directly proportional. The second mark is for writing this statement, it exceeds the limit of proportionality, or you can also say the elastic limit. That's the second point. So it is important to write the second point that it exceeds the elastic limit. Question 2, any doubt? Question
No.
2, no doubt. Question number 3, any doubt? Question 3. Question number 4, any doubt? Question 4, part A, B. Question 5, any doubt? What is the effect of center of gravity when it is high? When center of gravity is higher, the object will be less stable. It can topple easily. But when center of gravity is lower, the object is more stable. That's the effect. Question 5, no doubt? Feel free to ask your
No.
doubts if you have. Question 6, any doubt? Question 6.
Sir, I have a doubt in part, wait,
Yeah.
in part D
Part D. Okay. State and
as well
explain
as
where.
E.
Which one?
Part D and E.
D and E. Okay. State and explain whether the spring is obeying the Hooke's law. So how you can identify? First thing, you have to sketch a graph, like plot a graph here, but you are not supposed to draw a line. They mentioned do not draw the line through the points. So first we'll mark the points. Like when the weight is 0, the extension is also 0. So that's the first point. Okay. Then when a weight is 1, the extension is how much? 10 boxes equals to 2, 20. So each is representing 2. So this will be 21. Then we have 2 and 40. Sorry, this is. Then 2 and 40 is there. Then we have 3 and 51. So this is 3, 50, 51. Then we have 4 and 82. Then we have 5 and 103. Somewhat, it will be like this. Then we don't have to draw then the student appear to have made an error on one of the results. Which result is this? So which results appear to be an error in this one?
E.
When you plot these results, so when we have these results, which one appear to be an error? So how you identify that which one appear to be an error? This point at 3 Newton, because if it is obeying the Hooke's law, it should be a straight line passing through the origin. So if I try to draw a straight line which is passing through origin, so this point does not appear in the line, like the point at 3. So means the point at 3 Newton does not appear on line, so means this looks an error. Yes, Abdullah.
Sir, I've drawn gradients instead of points or these dots here.
Instead of?
Instead of these dots, I've drawn gradients.
No. It means if you did like this, like you did like this.
Oh,
This is what you
yes.
did? No, that's not the way to plot the graph. You're supposed to mark the points only. If they ask us to find the gradient, then only will you use this method. But if they don't ask us to find the gradient, we just mark the points.
No, then I have drawn a straight line to
No,
on the
you,
points.
I got
to
your
the
point. Like you have drawn a straight line through those points and identify, but the problem, what you did is, this is not the way of plotting a graph. Where you just need a single point for that when you're plotting a graph. Like if then your graph will look like this, the one which you plotted. So this is not the way of plotting a graph. When we plot a graph, we just mark those points only. If they ask us to find the gradient, then this is a triangle method which we use.
Okay.
So the point at 3 Newton appear to be incorrect because that does not lie on the straight line. Then state and explain whether if it is obeying a Hooke's law, what is the condition? It should be a straight line and it should pass through origin. So state and explain whether the spring obeys the Hooke's law. We'll say yes. And the reason is that because it is a straight line, passing through origin or
So
starting.
what's the for E?
Which one?
Sorry, I have a question.
E.
Part E.
Yeah.
This is the part which appear to be incorrect. That is a 3 Newton. And ignore the incorrect. Then draw a best fit straight line that we did. Then describe how the graph might be shaped if a student continue to add several more weights. So if you are adding more weights, what will happen? Eventually, it will not obey the Hooke's law, or it will become curve. And which direction the curve will bend? It will bend
Towards
towards extension axis. So in this case, where we have the extension axis, so y-axis is the extension axis. So if this was our graph, original graph was like this.
So, but I've only written that the spring would curve.
So yeah, that's fine. It will bend or it will become non-linear. But on the graph, they ask us to describe. So in a description, we will mention the graph will become non-linear or curve or bend. That's only we will say.
Okay.
So I have a question.
Yes.
In C part, sir, in D part, can I write in the justification that the extension is directly proportional to the force applied to it instead of that the straight line is passing throughout the
No, because the
diagram?
question was related to the graph, as you can see. Yeah, state and explain whether the spring is obeying Hooke's law. So how you can identify a spring obeying Hooke's law? You have to understand that if anything like force and extension are directly proportional, that is a Hooke's law. But you always use a reference of the graph when a graph is given. Because in this case, the graph is given, so the marks are for reference of the graph. If the graph was not given and they say the spring is obeying a Hooke's law, then we'll say force and extension are directly proportional, or the ratio between them is constant. So when the graph is given, you have to justify from the graph.
Clear, sir.
Question 7, any doubt? Question 7,
No, sir.
no doubt. No doubt in 7? Usually students have doubt in 7, that's why I'm amazed.
Sir,
Question
can you
8,
show question 7 again?
this is question 7.
No
I'll
doubt.
discuss. Okay, no doubt. So then, fine. Question 8, any doubt? Question 8.
Yes, sir.
No doubt in question 8?
No.
Okay, good. Question 7, I will just discuss because usually students have doubts, but I'm amazed that this group not having any doubt in this. But this is a common doubt. That's why I just want to discuss. See, in this question, state the range of a load which S obeys the Hooke's law. So it is obeying the Hooke's law from, because this is a linear part. When it is a straight line graph, it means it is obeying a Hooke's law. So this linear part, it started from 0 and ending at 8. So from 0 newtons to 8 Newton, it is obeying the Hooke's law. Use information, determine the spring constant. So how to get the spring constant? Spring constant is force divided by extension. So I will take any value of the force. It's up to you, any value of a force and relative extension, and you divide, you'll get the value for the K. So, for example, even if I'm taking 8 till it is obeying the Hooke's law, if I'm taking 8 Newton, and this is 10 boxes equals to 10, each is representing 1. So this is representing 15 centimeter. So spring constant, yes, Abdullah.
Sir, unfortunately, I've written the spring obeys Hooke's law from 1 Newton to 8 Newton instead of
It
0
should
Newton.
be because it's a straight line from 0. That's why. So we'll do 8 divided by 15. So when we do 8 divided by 15, so we'll get at 0.53 newtons per centimeter. That's the spring constant. Then the spring is there. You can see the second spring identical. The two springs are attached and a load of 4 Newton is suspended. Like we attach a load of 4 Newton. State the name of energy, name of form of energy stored in the two spring. Elastic strain energy when object deformed, they have elastic strain energy. Determine the extension. When we attach a load of a 4 Newton, so means this will experience a load of 4 Newton and this will also experience a load of 4 Newton. So each spring, because if they were connected side by side, like this, the two springs with a load of a 4 Newton, then what will happen? This will experience 2 Newton and this will experience 2 Newton. But when they're attached end to end, so each spring will experience the same force what is attached. So if we attach 4 Newton, so each will experience 4 Newton. So what we do for a load of a 4 Newton, we'll find the extension. So for a load of 4 Newton, we'll find the extension. So this is about 7.5. So 7.5 centimeters extension for one spring. But as the two springs are attached end to end, so if we have a 4 Newton, this increases by 7.5. This also increases by 7.5. The question is, what is the total extension of these springs? So each extended by 7.5. So 7.5 plus 7.5. So the total extension or the increase in the length will be 15 centimeter. So 15 centimeters is the answer for the part there, like C2. And then the load is carefully increased to 6 Newton. Calculate the distance moved when load increased from 4 Newtons to 6 Newton. Look, when it was 4 Newtons, the extension was 7 and the total length was 15. Total extension was 15. Now, the load is 6 Newton. When a load is 6 Newton, how much is the extension? It is 11. That 11 centimeter for 1. For 2, how much? 11 plus 11, so the total will be 22 centimeter. So the question is how much it has increased or what is the change in the length when the load increased from 4 Newton to 6 Newton. So when the load was 4 Newton, the total length of the two spring, like extension of the two spring was 15. When a load is 6 Newton, the total extension is 22. So how much it is increased? So it will be 22 minus 15. So 22 minus 15, what we'll get? We'll get 7 centimeters. So 7 centimeter is an increase in length. Or 7.5, you can also write 7.5. Is it clear, this one?
Yeah.
Yes.
Okay. So this was our exercise related to the Hooke's law.